Well, hello there. This is KP the Math G. I got my KP cap on. I don't have the Math G yet. I may do that a little bit later, but I'm satisfied that I just got that KP cap on, and I'm just so delighted that I'm able to do another video for you. I'm hoping whether you're a teacher or a student. This is a really good video. This one right here. This will make my 140th video. I'm proud of that. All of them are calculus based. I'm going to try to get up to 150, maybe more than that. But this is where we're at right now. Let's take a look at this video, or this problem in particular. I love this problem. I want to tell you, if you are a beginning teacher, this is your first year to teach, and you've taught them the power rule of the derivative, the product rule, the quotient rule, and the chain rule, then of course this is where you need to go, because isn't this what this is all about? This is a graph of h here. This is a table. It's supposed to be of course it's going to be differentiable. You can't do anything if it's not differentiable, but it's differentiable over G, and that means that G is continuous. If something's differentiable, it is continuous. That should be automatic. And then of course we have an equation, a function of f. So a function of h in the form of a graph. The function of, this is a piecewise graph of 5 segments, from -5 to +5 over that closed interval. And then of course G is, this is a function of G, this is a function of f. That's why I like it so much. I'm really fond of this question. And whether we cover all 4 of these or not, we do know that one of these, like part C, does take a little bit of time. I don't know if I'll do A and B first and then C and D later. All of this has to do with knowing how to find the derivative. And so even if you are familiar, even if you're a student and you're familiar with this, this is good review, real excellent review. So let's dive right in. And I know it's summertime and all that. For me it is anyway, or at least during this time it is. And maybe a lot of people are on vacation, but this will help you. If you're a beginning student, this is your first year to take calculus, you're getting in the AP calculus, and I don't know how much you could do here, but you have to know certain derivatives. And so this will help you. If you are already familiar with derivatives, all the different types, then this will be very helpful to you. Very helpful. Well, let's dive right in. This is a 2017 free response question number 6. And of course it talks about each one of these being differentiable, of course. And then of course they talk about some individually, some of them they put together. That's okay, I like it, it's all good. So find the slope of the tangent line to F. So we're just finding the slope. So if you're a teacher and you see this word slope, you know what to do, don't you? Slope, you're finding the derivative. Alright, so I want to find the derivative of F, alright, of the tangent line to F at x equals pi. Alright, so here we go. This is F. Well, I like to do F prime at x. I don't like to put the number in right away, so I'm just going to go ahead with F prime at x. If you look at these very closely, whether you're a student or a teacher, what are you looking at here? What kind of derivative are both of these actually? That's right, yeah, the chain rule. Alright, so we got to deal with the derivative of cosine first. We don't deal with the 2x just now. Derivative of e, well, that's just the same thing. And then you got to take the derivative of sine here. Alright, so here's how we do it. Derivative of cosine, anything that ends in a C, remember the derivative is going to be negative, but the antiderivative of cosine is not negative, it's positive. It's working in the reverse order, isn't it? So this derivative is going to be negative sine of 2x. Now this derivative of 2x here is just 2, so you're going to do that. Keep going, so plus e to the sine x. Now remember, students, do not stop here. The derivative of e to the x is e to the x, but not anything else, okay? E to the 2x is 2e to the 2x. Alright, so e to the sine x is e to the sine x times the derivative of what's up here, sine x, which is cosine x. Alright, so keep that kind of stuff in mind. Keep this in mind. Don't just say negative sine 2x and forget about this derivative inside of here. Inside of what's called an argument here. Okay. Now I want f prime at pi. Alright, negative sine of 2 times pi, which is just 2 pi, right? Sine of 2 pi times 2 plus e sine of pi times cosine of pi. Now, it would help if you knew what this graph looks like, okay? Actually, the period is pi. If you divide 2 divided by 2 pi, you're just going to get, well, anyway, 2 pi divided by 2 is just pi. So your period is pi, but we're not worried about that. I always like to think that if you can get pi, you can get 2 pi. Actually, the sign is actually, I mean, if you had to draw this graph, and I like to do that. Sometimes if you've got a calculator, you can easily get that. It's going to be 0. But I mean, it's really going to be instead the negative, and of course the altitude is 2. We're not concerned about that. But as the graph goes this way, the other goes this way, and of course it's only it's going to be at pi anyway. But anyway, it's going to be at 0 right there. Okay, and so anyway, that helps to know how to get this graph. This is all 0 here, so in this case here we have f prime at pi, okay, is equal to 0, negative 0 times 2, which we know that that's just 0, plus e to the sine of 0 times, let's just put it over here, plus e to the sine of 0 times cosine of 0. Now if you know your table, that would be easy. Sine of 0 is 0, but e to the 0 is 1. Don't make this 0 here. Sine of 0 is 0, but this is e to the 0. So this is actually 0. Okay, well, let's just leave that off there. This part right here is equal to 0 plus e to the 0. Cosine of 0 is 1. Alright, I'll just do that real quickly. Cosine of 0, cosine does this right here. Remember, cosine of 0 is 1. Sine of 0 0 is 0 right here. Okay, so this is cosine. Okay, this is sine. All right, like that. So this is just 1. So 0, 0 plus 1 times 1 is 1. Okay. All right. So let me see here. Oh, cosine of pi. I'm sorry. I put. Oh my goodness. Why did I do that? It's sine of pi, cosine of pi. Well, still sine of pi is. Oh my goodness. It's still 0. But cosine of pi is -1. So yeah, oh my goodness. Okay. So 0 plus 8. I don't know why I put 0 here when it's pi. Okay, anyway. Alright, so this first part right here is 0. All of this is 0. This is 1. And this is -1. So 0 plus -1 is -1. So in that first one you should have -1 right there. Yeah. Oh my goodness. Sometimes I don't know. It may be the heat or something. Even if I have an air conditioner on right here, I don't know what's. Maybe my brain's just getting a little overheated here. All right. Hey, our little cat right here is here. There's a little cat, and she just wanted to come in here and learn a little calculus. Okay. Okay. Well, oh, nope, she's going back out the door, so I guess she heard the word calculus, so she just ran out right there real quick like. Alright, so let's go to B. Sorry about this. This is sine of pi, this is cosine of pi. Oh my goodness. Okay. Maybe I won't keep making these same mistakes over and over. So, alright, I apologize. Well, KP the Map G makes mistakes sometimes. But at least I caught my mistake. That's the good part. Alright. Alright, so we dealt with A. That dealt with F. We may have F again. I think we do, but let's see what we got here. Alright, B part. Let K be the function. K at X. So B is K at X is equal to, what is K at X equal to? Alright, H at F at X. H at F at X. Okay, now we need to find K prime. I want to say they're wanting to find K prime pi. Yep, that's what it is. Well, let's take a look right here. What does this remind you of? Yeah, we might say that's a composite function. It's kind of like this. This is like cosine of 2x e to the sine of x, right? Alright, so remember you just take the derivative of the h first. Alright, so we're just going to actually find, so K prime at x. Alright, remember you just take the derivative of h prime, alright, f at x, times, now the derivative of this, which is just f prime. Just put the prime symbol up there. That's the chain rule right there. See that? Now, K prime at pi. So we're dealing with h prime at f at pi, alright, times f prime at pi. Pi, look at me. Alright, well, okay, bear with me. There we go. Alright, so this is h prime f at pi. So f at pi. So we're going to put pi in here and here. So f at pi is equal to cosine of 2 times pi plus e to the sine of pi. Alright. We're just finding f, not f prime. Okay, I think we found f prime at pi. Remember from the last problem, f prime at pi was equal to -1. Okay. We've already established that one. Here's this one, 2 pi, cosine of 2 pi. Alright, remember, cosine does this. Alright, and of course, this is going to be 2 pi. This is a period of 2, just pi. But anyway, alright. So anyway, you're down to this, and it's going to be 1, isn't it? So this is 1 plus, alright, so remember e to the sine of pi is e to the 0. We did that last time. E to the 0 is 1, so that equals 1 plus 1, which is 2. Alright, so that is f at pi is 2. Alright, so I'm going to erase this so I can have room to work. That's all we found right there, just that. So here we are, h prime at 2, okay, times f prime at pi. Alright, remember we found that to be -1 from the last problem. I think that's what we had to do. Well, that was the slope of the tangent line. Okay, that was anyway, you had to find that. I'm thinking that's correct. Okay. And then h prime at 2. Alright, so h prime at 2. Alright, I need to know what this slope is. Here's 2 right here. I want to find out what this slope is right here. Don't I? Because this is h prime. We don't want to look at h at 2. There is another problem when we look at h at 2, but this is h prime at 2, which means we're finding the slope here. Well, we know that this point here is 0, 0. Oops, sorry. 0, 0. Okay, 0, 0. And this point is 3, -1, so we can do the slope formula. Alright, so h prime at 2 is equal to -1 minus 0. And you could do rise over run if you wanted to. I guess I didn't think of that, but anyway, this is -1/3. Okay, so this is -1/3 times -1, which is +1/3. And that's it, +1/3. Okay, so we had to find this slope here, h prime at 2. Okay, and we could have done rise over run, run up 1 and left 3. So that would have been a -1, well, +1 over -3, or just -1/3. So, yeah, we could have done that. And I remember from this last one, f prime at pi is -1. So sometimes they use that last problem. So if you're a teacher, you just kind of keep that in mind to keep that last problem together. I just have to erase this for convenience sake, okay? Let's go ahead and try C. I don't know if we'll have time for that, or if my camera cuts off after 30 minutes. So bear with me. If it does cut off, just know that, well, my 30 minutes is up. Usually it'll go like 31 minutes. Sometimes if I'm lucky it'll go 32 minutes. Let's see if we can do part 3. I don't know if I can get it or not. This takes a little bit, but let's see what it says anyway. Alright, so m at x, okay, m at x is equal to, let's see, it's g at negative 2x, g at negative 2x, that's chain rule, isn't it? G at negative 2x times h at x. So we want to find what? Let's see, m prime at 2. Alright, so m prime at 2. Okay. I don't put the 2 in there right off the bat, but anyway, that's, you could have probably if you wanted to, but this is a chain rule, so let's see, we've got to really do it, I'd like to do it this way. Alright, so the chain rule is m prime at x is equal to, now, g prime at negative 2x times, now derivative of negative 2x is negative 2. Alright, keep that in mind. You got to get that. You've got to do that inside. That's why it's not wise to go ahead and plug that in. You cannot, you don't need to do that. Alright, now this is, okay, this is the derivative of the first times the second, h at x, plus the derivative of the second, h prime at x is the second, here's the first, here's the second, alright, times the first, so g at negative 2x. Okay, right there. So that is the chain rule, and not only the chain, but the product, a combination of chain and product together. Alright, so now we can plug in m prime at, so m prime at 2. I already have it here. Let's see if I can do it down here. It equals, okay, let's see, g prime at negative 2 times 2, plugging that in now, times negative 2, okay, so times negative 2 times h at 2, we gotta find h at 2, alright, plus h prime at 2 times g at negative 2 times 2, which really is negative 4 here, so let's go ahead and do that. Negative 2 times 2 is negative 4. We can do that, okay. Alright, all of that. Okay, let's see what we got here. Alright, the derivative of the first times the second, plus the derivative of the second times the first. Alright, I'm trusting everything's right here. G prime at 4. Alright, now we're in the G prime. G prime at negative 4, rather, is negative 1. So over here, I'm just going to kind of, I'm just going to see if I can put it right here. Now let's put it in a different color. Okay, g prime at negative 4 is negative 1. Alright, times negative 2 times h at 2. Alright, h at 2. Now I need to know what this point here is. I don't know. Let's not guess at it and say, oh, that looks like it's about half or about 3/4 of the way or 2/3 of the way or whatever. We can't guess at it. But I can come up with an equation of this segment here. So let's see, I can use 0, 0. So y minus 0 is equal to m. We know the slope from last problem is negative 1/3 times x minus 0. Okay, like that, which is really y is equal to negative 1/3 x. If I plug in 2, which I'm supposed to, so it's going to be y is equal to negative 1/3 times 2, 2 over 1, which is negative 2/3. Alright, so this part right here is, alright, I'm down to here, so times negative 2/3, okay, so plus h prime at 2, h prime at 2, alright, I found that already to be negative 1/3, didn't I, from the last problem, and g at negative 4 rather, negative, this should be negative here. Alright, g at negative 4 is simply 5, so times 5, or 5 over 1. Alright, all of this is over 1 if you want to. So what we got is 3 negatives, let's see, the negative, let's see, that's going to be negative 1 times negative 2 is 2, 2 times negative 2 is negative 4, so negative 4/3 plus negative 5, let's see, thirds. Alright, that's equal to negative 9/3, which is negative 3. Alright, that takes care of that one. That's a lot, because one thing you had to find h at 2, and then you had to find h prime at 2, and I remember that h prime at 2 was negative 1/3. Okay, this happens to be negative 2/3 of the way down. Okay, that's not drawn the scale. Okay, that's one reason you need to find the answer. You're gonna have to use an equation to get that. Okay, that's the one thing about it. You got to come up with this equation to be able to do that. 0, 0 is as good as any. You could have used 3, negative 1. You would have gotten the same answer. Okay, either way. But you got to know this combination of well, product rule, chain rule, and product rule together. You've got to be able to do that, okay? Alright, there's that. The last one should be fast. If I run out of time, please know that I'm just trying to get all 4 of these. I was hoping maybe I could do both of these, but do this twice. Let's see, do 2 videos on this, but I'm going to try to cram in 1 video now. I don't know if I can do it or not. I don't know how much time has elapsed really, so well, let's see what we got. Let's see if we can do it. Alright, is there a number C enclosed in the closed interval between, alright, so is there a number C, alright, enclosed, alright, in the closed interval, alright, so closed interval, alright, closed interval from -5 to -3, I think it is. I want to say that's right. Such that G at C is equal to C, my goodness, is equal to -4. G prime at C, isn't it? Yeah, G prime at C. Now, this, is there a number C? Usually when you see that, is there a number C, you're probably looking at, most likely all the time, you're looking for the mean value theorem. So here's what you got to do, is you got to say, well, here's your mean value. So you got to figure out between -3 and 5. So we know that G at -3 is 2. Alright, so G at -3 minus G at -5 over -3 minus 5. Okay, minus -5 rather, I'm sorry, minus -5. Okay, it's kind of like this is slope, isn't it? So G at -3 is 2, G at -5 is 10. All right, here we go. This is going to be negative 8 over, all right, plus over 2, which is negative 4. Okay, what you got to say is this, is because G is differentiable, G is continuous, all right, and probably you're going to say, when you're dealing with the mean value theorem, it's continuous over this open interval, negative 5, negative 3. All right, if it is continuous over that, then you got to say that. You got to put that down. There's the continuity, because G is